Hi guys, so I'm going to be doing more examples from section 7.4. So I'll start with the two very basic examples just to review what we did last time, and then I'll do these three homework problems from section 7.4, and then I'll do one that involves a quadratic equation. Okay, so let's start with our very first basic example, and that is I'm going to solve for sine of theta, and I want to figure out what angle would give me root 3 over 2, and simply solve for all degree solutions. Okay, so sine of theta is equal to root 3 over 2. We want to solve for all values of theta such that when I plug it into this equation, it will be true. So root 3 over 2 is a very nice value on the unit circle. We actually do know the position that would give us this value for sine. Sine on the unit circle would give us back the y value. So there is a position over here in the first quadrant with the y value being root 3 over 2. And I know this position pretty well because it comes from this special right triangle. This is being root 3 over 2. This would be 1/2. So here this guy is 60 degrees. Now, is that the only position on the unit circle that would give us root 3 over 2 as the y value? No, there is another position, and that's in this second quadrant. And for the second quadrant, the y value is also positive, and there is a position that would give us the y value being root 3 over 2 as well. And the unit circle being very symmetrical means that this angle, this reference angle, is also 60 degrees. Okay, so what is the angle for this very first position? For this very first position, theta can be 60 degrees. Okay, and that is one of the infinitely many solutions. So why is 60 degrees a solution? Because then I know that sine of 60 degrees will give me root 3 over 2. Okay. Is 60 degrees the only way to get to this position? And the answer is no. Instead of going 60 degrees only, maybe I can go 60 degrees and another 360. So what is that? Or you can think of this as 360 and then go another additional 60 degrees. So that's a 360 rotation with 60 degree rotation further. So 360 plus 60 is going to give me 420. And this is just another coterminal angle to the 60 degrees. I can add another 60 degrees on top of that and get that same position. So 420 plus 360, 360. So that's going to be a 780, I believe. And why stop there? I can add another 360 to this guy to get another coterminal angle to this 60 degrees. And it keeps on going. Okay? So this one position would have infinitely many values that would give us this one position. The first few values would be 60, 420, 780. And that is not the only position that would give me this y value, root 3 over 2. There is this second position. And in order to get to this second position, you would need to rotate a degree of, well, it's 60 degrees less than 180. So this position would have a degree of 120. Is 120 the only way to get to this position? And the answer is no. We know that there's infinitely many angles that would give us this one position, because as you rotate around the circle, you come back to the same position. So I can do a 360 and then the 120. So what's 360 plus 120? That is going to be a 480. Right? You take this guy, you add another 360, you get another coterminal angle to this 120. So the value is different, but it'll give us the same position in the second quadrant. You can add another 360 to this guy. So that'll give me an 840. And you can keep on adding a 360 to get another value that will give me the same position. So really the answer is an infinite list of values for theta. So it is impossible to list everything. But I do know the relationship between this angle and this angle and this angle. So there is a very nice way to just generate all these solutions. You start with any of the value. Usually you start with the first value, so let's say 60 degrees, and I can get another answer by adding 360 to it, or any multiple of 360 really. So you describe that by saying 60 degrees plus k times 360, where k is any integer. So for example, this guy would be when k is 1. When k is 1, you're adding just 360 to 60, and that gives you a 420. This guy is when k is 2. So when you plug in k being 2, that's 360 times 2, which is 720. And then you take 720 plus 60, that gives you a 780. Okay, and the next value would be when k is 3. The next value after that would be when k is 4, and so on. So this nice shorthand notation would just give us this whole infinite list. Okay. But that is not the only position. This would generate all the values for that first position, but I want to generate all the values for that second position as well. So you start with any of these angle. Usually I start with the first one, and then you can add any multiple 360 to this guy, and it will give you another coterminal angle to the same position. So for example, this 420 is when k is 1, and this 840 is when k is 2. So when k is 1, you take 360 plus 120 and you get 480. When k is 2, you take 360 times 2, which is 720. You add that with 120 and you get 840. So this here would represent this infinite list. Okay? So when you have the lists of solutions to be an infinite list, you do have to get a little bit creative, and this is how you would do it. Okay, that's my very first basic example. Let's try another one, but this time let's try with radian. So, and I'm going to use x. So cosine of x is equal to negative 1/2. It's a very basic trig equation. I'm just looking for all angles x, that would give me cosine of x being negative 1/2. But here the condition would be find all real values of x. So we want to find all the solution, but we want to find the real value of x. And this is just another way of saying you want the answer to be in radian. Okay? So instead of using degrees, we're going to focus on x being a in the unit of radian. Okay, so let's go back to the unit circle. Cosine of what will give you a negative 1/2? So what angle, remember cosine gives me back the x value. So this represents the x value on the unit circle. So negative 1/2, if my x value is negative 1/2, I am going to be either in the second quadrant or the third quadrant, and there is a position in this second quadrant that will give me a negative 1/2, but there is another position in this third quadrant that would also give me a negative 1/2 for my x. And I don't really care about the y, right? Okay, so what is the angle that would give me this position? And what would be the angle that would give me this position? Well, 1/2, which is my x value, is the side of this right triangle where the hypotenuse is 1. We know this triangle pretty well. This would be root 3/2. And so I do know that my reference angle is 60 degrees, and this reference angle down here is also 60 degrees. And so in order to get this very first position, being that the reference angle is 60 degrees, to get to this position, it is 60 degrees less than 180. So my very first value, you're very tempted to write 120, but even though that's correct, we only want the answer to be in radian. So what is 120 in terms of radian? At this point, you should know this off the top of your head. It is 2 pi over 3. Okay, is that the only way to get to this position? Well, you can add a 2 pi to it. So another value after this would be 2 pi over 3 plus 2 pi, right? I'm not going to bother combining it together, but this is just saying that you go around the circle once and then you go 2 pi over 3. You end up at the same position. Why add 2 pi? You can add 4 pi. And this just means I'm going to go around the circle twice and then go 2 pi over 3. You end up at the same position. And this list keeps on going forever, right? This one position would generate infinitely many values that would give you this same position. Okay, well, that is not the only position that would give me the x value as negative 1/2. Here you have the second position in the third quadrant, and to get to this position, it is 60 degrees more than 180. So that's really 240, but that's in degree. We want to use radian. So in radian, that's a pi, and 60 degrees is pi third more. So this position is pi plus pi third, which is 4 pi over 3. So my very first value is 4 pi over 3. And I've been adding 2 pi, but you could actually subtract 2 pi. That just means you actually went clockwise and then counterclockwise. Doesn't really matter, right? So adding or subtracting 2 pi just means you're either going clockwise or counterclockwise, but it does not change where you end up at. Okay, so 4 pi over 3 is going to give me this position, but I could have gone 2 pi and then 4 pi over 3. And then, so that's the same as saying 4 pi over 3 plus an additional 2 pi. This will give me the same position, and so I will end up with the x value being -1/2 as well. What's another value that will give me this same position? Well, 4 pi over 3 plus 4 pi, and so on. The third one will be 4 pi over 3 plus 6 pi. Okay? So there's infinitely many values that will give me this, either this first position or the second position, and it'll both of these positions will give me the x value being -1/2. And so the answer is an infinite list. You cannot list everything out, but you can see the relationship between all these values. All these values give me this first position, but all of them is just really 2 pi over 3 plus any multiple of 2 pi. So I would write that as plus 2 pi times k, where k is any integer. So for this guy, k is a 1, because it's 2 pi times 1. For this one, k is a 2. So 2 pi times 2 is 4 pi. Okay? How do I generate this list for the second position? Well, it will be 4 pi over 3 plus any multiple of 2 pi. So this would be when it's 1. This guy would be when it's 2. This would be when it's 3. And how about this? Well, it's when k is 0. So when k is 0, it's just 4 pi over 3. So you actually do get everything. This guy is when k is 0 as well. So this is just a very convenient way of denoting this infinite list as your solution. Okay? And I'll be holding a Zoom conference on Friday night and Saturday night. So if you guys have more questions to ask, you can come to the Zoom conference, and I'll happily go over everything again with you guys. Okay? All right, so that's my second basic example, just so you guys understand how I go from this list to this notation with the k. All right. So now I'm going to do a few examples where the angle is not nice. So the three examples would be number 11, and then 20, 30, and then 31. So let's start with 11. So 11, you have sine of theta is equal to -0.45. That is not a nice value for sine. I have to figure out what angle would give me this value. Well, sine is going to give me a y value. So this is my y value. So I can at least narrow it down to what quadrant I should be in, such that my y value is a negative. It can't be in the first quadrant because that's when my y value is positive. It cannot be in the second quadrant because then my y value is a positive in the second quadrant. Here my y value is a negative. Therefore, I'm either in the third quadrant or the fourth. Now, there is a position where my y value is a -0.45. Y value. There is also another position in the fourth quadrant where my y value is -0.45. It's not a nice triangle, so don't even try to figure out the sides of these triangle. You have to use your calculator. So in this case, you have to do inverse sine. So if sine theta is equal to negative 0.45, you can say theta must be the sine inverse of negative 0.45. So that's what I'm going to enter into my calculator. Before I do that, let me just say that you want theta to be in radian, okay? So when I use my calculator, I want to make sure my my unit is in radian. Right now it's in degree. So for my calculator, I have this little button right here that I'm going to press, DRG. It's going to switch over to radian, and that means I'm in the right unit. And so theta would be sine inverse of negative 0.45. So I'm going to evaluate the sine inverse. That's a sine. In order to get sine inverse, I do second, press sine, and that'll give me that sine inverse. Oh, yeah, I have to enter in. So my calculator is not that fancy. So I have to enter in 0.45. It'd be a negative 0.45. And then I want to take the sine inverse of this guy. So for my calculator, I enter in the input value, and then I apply the function. For you guys, if your calculator is a little bit more advanced than mine, you would do the function and then enter in the value. So it really depends, okay? So I enter in the value for the sine inverse, and then I apply the function, which is sine inverse, second sine, and there it is. That's in radian. Okay, so my very first answer is this guy. Now remember, we are in, so I'm just gonna use, just gonna round it off to 2 decimal places, maybe 3, so 6, 7, okay? Remember, we're in radian, so that's a 0, that's a pi half, and what is pi half? And if you go down here, that's a negative pi half. So remember pi, if I do pi, that's a 3.14 around there. Half of that is 1.57. So up here is a 1.57. Down here is a negative 1.57. So how about this guy? Negative 0.467. It's right here. So this position is this value, right? Negative 0.467 will give me this position. And if you go down here, it'll be negative 1.57. Okay. Recall that the range of sine inverse is that it's only going to give you back an angle between negative pi half to pi half. So it makes sense that for this position, it gives me a negative because this value is in between this negative pi half and pi half. Okay. Is this the only value that would give me this position? No. I can do a 2 pi and then go down back a negative 0.467. So another way of saying that is I can take this and add or subtract 2 pi and I will get that same position, right? Adding 2 pi just means you go counterclockwise a full circle. Subtracting 2 pi just means you go clockwise a full circle. But you do not change position. So another answer would be this value plus 2 pi. Or that same value plus 4 pi plus 6 pi would be another answer, and so on. Okay, so all of this would just generate that first position. So let me write the answer right here. So a negative 0.467 plus any multiple of 2 pi would give me all the values that would give me this position, and that would give me the y value of a negative 0.45. Okay, that is not the only position. By the symmetry of the circle, I know there is another position over here in this third quadrant. But your calculator will not give you this position. Remember, your calculator, if you do a sine inverse, it will give you a value between negative pi half and pi half. So your calculator would not give you this position. You will have to figure out this position by using the symmetry of this unit circle. So I know that this guy had to go down from the 0 position of a negative 0.467. Okay, so the reference angle is a 0.467. That means that the reference angle for this guy is also a 0.467. So in order to get to this position, what I have to do is I have to go pi and then another 0.467. So this position, to get to this position, would be pi. And then on top of that, you have to go an additional 0.467. So that's going to be the position for this second solution. Okay, is this the only value that would give you this position? No, you can add a 2 pi to this, which is really 3 pi. Or you can add another 2 pi to that guy, and that would be a 4 pi. Okay. So I'm actually not going to combine this together. We're going to keep it like this so you guys can kind of see the pattern. So what's another solution? You added 6 pi. So how do I generate all these values? Well, it will be the pi plus 0.467 plus any multiple of 2 pi. And that will give you all the values that will give you this second position. So here it is. This is the answer. Okay? Okay, so once you see the solution for number 11, you can probably figure out the solution for the next 2 examples. So 23. 23, the equation is pretty simple. It's tangent is negative 10. Okay. So we do have to kind of figure out what position on the unit circle will give us the tangent value being a negative. Well, tangent, if you recall, is sine over cosine, or tangent theta is really the y value over the x value. Now, if you take the ratio of the y over the x and you get a negative, that says something about the sign of y and x. They can't be both positive. So if y and x are both positive, you would not get this negative. So right away, I know that I'm not going to be in the first quadrant, because the first quadrant, both y and x are positive. But at the same time, I cannot be in the third quadrant because for the third quadrant, both the x and the y are negative. But if you take a negative divided by a negative, that would be a positive. So that would not give you a negative 10. The only way to get a negative 10 is if one of them is positive, the other guy is negative. So what are the two quadrants? Well, it will be the second quadrant where x is negative and y is positive. So the ratio of the two would give you a negative. But also the fourth quadrant where the x is positive and the y is negative. And I just have to figure out for what position such that the y over x would give you a negative 10. And it's probably one where the y is a lot bigger than the x, right? The y is actually 10 times bigger than x. That's how you get a 10 as the ratio. So if I have to guess for a position on the second quadrant, it's probably right here, where the y is 10 times bigger than x. And you can probably figure out the position is just 180 degree from that first position in the fourth quadrant, because this is also going to give me the y value being 10 times bigger than oops, I drew that wrong. 10 times bigger than x. And now our goal is to figure out these two positions. Okay? So we're going to take this equation and we're going to just get theta by itself, which means I need to do a tangent inverse of negative 10. I need to use my calculator to evaluate this. But recall that tangent inverse, the range of tangent inverse is that it's only going to give you back an angle between negative pi half and pi half. Right, we've learned about inverse trig. Tangent inverse is programmed to only give you back an angle between negative pi half and pi half. So when I want my answer to be in radian. So when I enter this in, tangent inverse of negative 10, so here's 10, negative 10. I'm going to apply this tangent inverse. That's the regular tangent function. To apply the tangent inverse, I'm going to do second tangent. And that is my radian. So my first solution, well, the solution that the calculator gives me is a negative 1.47. That is in radian. So remember, this position would be the 0 position. This position is a negative pi half, and you guys remember what negative pi half is? Negative pi half is a negative 1.57. Our position is negative 1.47, which is pretty close. And that makes sense because here I need my y to be 10 times bigger than my x for the ratio to be a negative 10. Okay, so I found my first position. It's a negative 1.47, which is really close to the negative 1.57, which is my pi half, negative pi half. Okay. So once you get the first value for that first position, you can generate infinitely many values for that same one position by just adding any multiple of 2 pi. Okay. All right. How do I get this other position? Well, by the symmetry of the unit circle, this other position is just pi away. So I can get to the second position by adding pi. So right away, I know that this position is just this negative 1.47 plus pi. What is another value for this position? It's a negative 1.47 plus pi plus 2 pi, or 3 pi. What's another value? Negative 1.47 plus pi plus 4 pi. Negative 1.47 plus pi plus 6 pi. And so you generate all the values for this other position by taking negative 1.47 plus pi plus 2 pi k. All right? And you notice something here. You actually only need one line. And the reason for this is that here, to get another value for this position, I add a 2 pi. To get another value for this position, I add another 2 pi. But you notice that these two positions are related by adding simply a pi. So I can start with this negative 1.47, add a pi, you get this other position. Add a pi, you get back the first position. Add another pi, you get back the second position. And then add another pi, you get back to the first position. So I can actually just use this negative 1.47 and just add a pi to it and not have to use this 2 pi. So if you add any multiple of pi, you'll either get that first position or the second position, depending on k being negative, being even or odd. Okay? So both answers are acceptable. It's just that this answer is a little bit more neat. Okay? And if you guys have any questions about this problem, I can explain further in our Zoom conference Friday night and Saturday night. Okay? So that's number 23. One more, and I'll make another video for the quadratic. Okay, 31. So 31, you have, I'm going to do this really quick. 3 tangent square theta minus 1 is equal to 0. The first thing you have to do is really solve for this tangent theta. So 3 tangent square theta is a 1. If you move that 1 over, that means tangent square theta is a 1/3. And I'm going to take the square root of both sides to get rid of that square. But here you have to consider the fact that tangent theta now can be a positive or a negative. So you have actually two equations to solve. Either tangent theta is positive root 1 over 2, or tangent theta is a negative root 1 over 3. It's either a positive root 1 over 3 or a negative root 1 over 3. Okay? All right, and then you have to solve for both. So this is very similar to question number 23, but here you have two equations to solve. For the first equation, if my tangent is positive, that means that I'm going to be in the first quadrant, somewhere in the first quadrant, or third quadrant. How do I know that? Well, in order to get a positive for tangent, the ratio of y over x would have to be both positive or both negative, right? If you take a positive divided by a positive, you get a positive. Or if you take a negative divided by a negative, you get a positive. So I know the two positions that would give me this value would be in the first quadrant or the third quadrant. How do I get the initial value for theta? Well, you apply tangent inverse, root 1 over 3. So let's do, so for me, I have to do a 1 divided by 3. Take the square root of that and apply the tangent inverse. And I got 0.52. Okay, so 0.52 is this very first position. How do I get that second position? By adding a pi. And then if I add a pi again, I get that first position back again. Add a pi, you get the second position. So you would generate all the values that would give you the first position or the second position by adding any multiple of pi. So that is it. This gives us all the values of theta that will give me this root 1 over 3 for a tangent. Let's solve that second equation. For the second equation, if I'm looking for any position on the unit circle that would give me a negative for a tangent, it would have to be in the second quadrant or the third quadrant, because then the y and x are opposite sign, and if you take opposite sign divide them, you get a negative. Okay? So I have to figure out these two positions. In order to get a value for theta, I have to use my calculator because this value is not a very nice value. Okay. Or maybe it is a nice value. Let's see. So if I take, just trying to see if this is a nice angle or not. If I take is a root 1 over 3, 1 over root 3. Yeah, and I think you get that by, if I take, no, I don't think so. I don't think that's a very nice angle. Yeah, so let's see. If I take root 3 over 2 divided by 1/2, you do the root 3. Oh, there we go. Okay, so it is a nice angle. I'll show you guys that in a bit. But assuming you don't really know that it's a nice angle, you can still go about solving it this way. So I'm going to complete this problem, assuming that I didn't know that theta turns out to be a pretty nice angle. Okay. All right. So how do I get a value that would give me this as my tangent? So I'm going to take the tangent inverse of negative root 1 over 3. So 1 divided by 3. Take the square root, but I want the negative of that. Now I'm going to take the tangent inverse, and that gives me a negative 0.52. Negative 0.52 is not going to be this position, right? Because here is a 1.57, that's a pi half, but a negative 0.52 means you're going clockwise. So this is the position for this value of negative 0.52. In order to get that second position, you add a pi. You add another pi, you get back to the first position. So in order to generate both of these positions, you start with this value and you add any multiple of pi. So the final answer for this problem would be the 0.52 plus any multiple of pi, the negative 0.52 plus any multiple of pi. Okay. And it turns out you can solve this without having to use the calculator, because it turns out this is a nice angle. So tangent theta is y over x, but if your y, so if your y is a 1/2 and your x is a √3 over 2, this is the same thing as 1/2 times 2 over √3, which is 1 over √3, which is the same thing as √1 over 3. So if you can figure out that angle where y is a 1/2, y is a 1/2, and my x is a √3 over 2, well, that's 30 degrees. And that's also 30 degrees, 30 degrees, 30 degrees, and it turns out the solution for theta would be, well, 30 degrees is pi over 6. So it'd be pi over 6 plus pi k, or negative pi over 6 plus pi k. So is pi over 6 going to give me this 0.52? Pi divided by 6. Yeah, there we go. So this is exactly the 0.52. It's pi over 6. Okay? Okay, so I'll stop here, and then I'll do another video for a quadratic type trig equation. All right? I'll see you guys next time.